MEVPool. This is joint work with Justin from Localhost Research. It's a new research and development shop on the West Coast in the Bay Area. They're doing cool work. You should check them out. But this is joint work with him. So before we can talk about MEVPool, first we have to set the stage a little bit about all the problems we have to deal with, and that's mostly MEVPool. And so to be clear, MEVPool is MEV that is evil, MEVPool. Just making sure everyone's really clear. This is the most important part of the talk right here. Just MEVPool. Everyone got that? All right. So that's MEVPool. All right, but how do we make MEVPool? How do we make this evil MEV? So it's really all about linearity of mining costs, or cost per hash. Right? So mining is designed to be this hyper-competitive industry where there's a lot of miners, there's a lot of small entrants. Hopefully it's highly decentralized. There's tons of miners across the globe. And that really only exists if we don't have massive economies of scale in the mining market, right? If it's the case that for a small miner, the cost that you spend to get one hash is roughly similar to the cost that a large miner spends to get one hash. And of course, there are economies of scale in the mining market. You know, you have a larger business, you can invest in better things. Larger things are often cheaper on a per unit basis, but there's also economies of scale in the mining market. It's often cheaper to get very small pockets of free or very cheap energy than it is to get very large pockets of cheap energy. And so these things do tend to kind of cancel each other out fairly effectively in practice. The mining market is highly decentralized in terms of who actually owns and operates ASICs, and this is great. We love this. This is how Bitcoin is supposed to work, and it's maybe almost a bit of a miracle that it is working that way. But what would happen if we suddenly introduced some, let's say, fixed costs to become a miner? If we introduced, let's say, tens of millions of dollars in additional fixed costs that every miner has to pay in order to effectively mine, that is just fixed. And so suddenly it's no longer a linear cost, right? So suddenly a large miner gets a substantial discount on their per hash cost than a small miner does. This would hopefully, it's very obvious, this would be highly problematic, right? This would drive a lot of centralization because suddenly large miners can continue to invest. They can invest in more hash rate and continue to drive up their advantage because they're getting larger, because they're more profitable. And suddenly, as they continue to get larger, these smaller miners start to go out of business because your per unit hash rate is just lower, and mining is almost a perfectly competitive, like theoretical economics, perfectly competitive industry. If you have higher costs than anybody else in this global industry, you will eventually go out of business. Okay, so this is some theoretical fixed cost issue, but how do we actually get this? What does this mean on a technical sense? How does MEVPool come about? And it's really this concept of transaction selection being expensive. It's expensive to build a block template. So let's imagine some magic thing that were to exist where if you want to create a block template, you want to say, here's a block template you're going to mine on, that is expensive. Say that costs, for example, $10 million a year. Suddenly you could hopefully see that mining would become very centralized, or at least pools. So okay, brief distraction, what is a miner for these purposes? I'm not trying to redefine common terms, I'm not trying to confuse anyone, but for at least the purposes of this talk, a miner is the transaction selection rate, creating that template, who is picking the transactions that go in a block. Because this is what matters to Bitcoin. The Bitcoin network has no conception of ASICs, it has no conception of pools, it doesn't have any idea what a Stratum client is. But the Bitcoin network sees transaction selections and transaction ordering, right? That's the job of miners, is to provide transaction ordering in the network and keep a consistent order and make it hard to undo or change that order after the fact, but to set the order of transactions, select the transactions that go in the block. That's the whole point of miners, and so that's what I'm going to refer to as a miner in this talk. And in the short term, kind of in today's Bitcoin, obviously that is pools. I mean, that should be fairly obvious. They're the ones who select the transactions that go in the block. But there's also, it's important to recognize, lots of important work being done to change that. right? Whether it's Stratum v2 and these technologies that allow miners to select transactions and build their own block templates as a part of a normal traditional pool, or whether it's something like P2Pool v2 or braid pool, these technologies that allow reviving, a totally decentralized pool. But again, the important part from the Bitcoin network's perspective is that the miners, these decentralized, very decentralized entities, are the ones picking the transactions that go in the block, ordering these transactions in over time. And yeah, also all of these rely on all of these new cool technologies that we want people to build and start to adopt, hopefully soon, rely on this property that it's cheap today to build a block template, right? To have a competitive block template, all you have to do is run Bitcoin Core and hit one RPC, and suddenly here's your block template, and it's super competitive. This is going to pay you roughly the same amount as any other miner. If, on the other hand, we were to imagine this theoretical change to Bitcoin, which results in building a block template being expensive, suddenly it's $10 million a year to get a block template from Bitcoin Core, again, it should be fairly obvious to you that all of these cool technologies that we think are really awesome, that are going to save Bitcoin's decentralization properties that are currently have big problems, just can't be adopted. Right? You would never be able to adopt a Stratum v2 or a P2Pool v2 or a braid pool or whatever if it were expensive to get a block template. It's just not practical. And this is part of why I worry so much about MEVPool, is because I've invested some time in actually helping get some of these things off the ground, Stratum v2, and encouraging people to build these. And I see these as kind of critical to the future of Bitcoin. Obviously, today's Bitcoin centralization is terrible, right? If you look at pool centralization, there's two entities selecting blocks, selecting block templates that have over 50% of hash rate. If you look at both Foundry and Antpool and Friends, which of course for the and Friends, it's Bitmain and Antpool selecting the block template. So whether it's a separate pool or not doesn't matter. Again, for the purpose of this talk, what is a miner is who selects the transactions that go in a block, and that's just Antpool. So we have two entities with more than 50% of the hash power. That's really bad. And so we want these technologies, Stratum v2, P2Pool v2, everything, to be adopted. And it's kind of key to fixing Bitcoin. Well, they couldn't be if we had this problem where building a block template's expensive. Okay, so what does this mean? I said that building a block template gets expensive. We're going to say throw out a number. It's $10 million a year to get a block template out of Bitcoin Core. That's obviously absurd. How the hell would that happen? Well, we should start by looking at Ethereum because that has happened in Ethereum, right? So in order to build a competitive block template in Ethereum, you have to invest tens of millions of dollars hiring the best engineers on the market, investing in the right data center and everything else, literally becoming a high-frequency trading firm in order to build a competitive block template. And so in Ethereum, what does this look like in practice? There's there's kind of two types, but really there's many types. I'm going to focus on two, or at least mention two. The first and the biggest one of this form of MEVPool in Ethereum, this thing that makes it expensive, is what's called sexdex arbitrage. So that's the centralized exchanges, so your Binance, your Coinbase, whatever, and your decentralized exchanges, so your Uniswap, whatever it is, the arbitrage just between those. And in order to effectively do that, you really do have to be a high-frequency trading firm. So in Ethereum, you know when the block is going to be found, and so you want to wait until the last millisecond to submit your block template so that you can get the latest price data from Binance, so that you can clear that price right before the block template. And it turns out doing that, being in the right data center, doing research on what the right data center is, and then also parking a ton of capital on-chain in this Uniswap pool or whatever, having it available for you to do this arbitrage, and then also parking a lot of capital at Binance so that you can do the arbitrage on the other side of the leg, it adds up. It gets very expensive. And so that's actually a majority or a plurality of the total MEV extraction in Ethereum is just this sexdex arbitrage. In fact, that the single, usually in Ethereum blocks, the very first transaction is the arbitrage transaction settling the Ethereum to USD price, just doing that arbitrage. As something like 10 to 20% of the total MEV extraction. Total cost to build a block template. The other one is just smart contract attacks. And this is one that's a little more nebulous. I'm going to keep it more nebulous, but should maybe be a little clearer that it's expensive, there's a lot of smart contracts in Ethereum, right? There's a lot of complexity, there's a lot of different things, there's a lot of weird casinos and weird shitcoins and whatever other nonsense, and DeFi and whatever stuff on Ethereum. There's a lot of complexity there, there's a lot of depth there. And if you want to build a competitive block template in Ethereum, you don't just need to collect transactions from people building transactions in the network. You also have to go look at all of these different smart contracts, all of the different things happening on chain. You need to be an expert in all of them so that you know how to stitch them together and exploit things in the right way, to do arbitrage between things, to, you know, take out a flash loan where you can go over here, take out a loan for infinite money, take it over here to this contract, crash the price of this thing, then buy this thing, and then take it over to this contract and buy this other thing to arbitrage out that price, and then you take it back and you pay back the loan, and it's all in the same transaction, and it's great, and you just made a bunch of money, but you have to know to do that, which means you need to understand everything happening. And so it should be hopefully relatively obvious that if you need to understand everything happening, you need to hire a lot of people, you need to hire the best people, and that's expensive. That's very expensive. And so we see this in Ethereum. If you look at these dashboards that are like, you know, 60, 70% of Ethereum blocks are OFAC compliant and are censoring, that's not just because proof of stake has some centralization problems. That's actually because of this MEV problem. So in Ethereum, there's only 2 or 3 companies that can competitively build a block template. It's not something where you can take open source software and run it and build a block template. No, there's only a few companies that are capable of it in a competitive way. You can take some open source template software and run it, but your block templates are going to pay you a lot less than what you were going to get if you went to their marketplaces. Okay, so what would this look like in Bitcoin? You know, the Ethereum has all these problems. We hate Ethereum, whatever, it's not our problem. You know, how could these things come to Bitcoin, and how could this pose a risk to us? So the first and very obvious things is there is some things coming down the pipeline that might end up bringing literally the Ethereum virtual machine, the entire Ethereum smart contracting platform onto Bitcoin. Right? And so that could be either a based rollup, so not all rollups. You know, a lot of people talk about bringing rollups to Bitcoin. Not all rollups would do that, but this technology called based rollups, where you literally allow the Bitcoin miners to select the Ethereum transactions that get included in the rollup, would obviously do this, because now the Bitcoin miners have to consider the Ethereum transactions. But also merge mine chains. If you have a merge mine chain with the EVM in it, well, again, you're back to the state where the Bitcoin miners, the people selecting the transactions that go in the Bitcoin blocks, have to select the transactions that go into this other Ethereum platform block, and they have to be aware of these things. And so a smart Bitcoin miner could build a block template that is more aware of these things, could do these kinds of exploits, and they could make more money than their competition. But I mean, those are the obvious, but you know, we could also have smaller cases of this, right? It doesn't have to be all or nothing. We could, for example, have native tokens on Bitcoin, where you have a USD token on Bitcoin on-chain, and if someone were to build a decentralized exchange with that, well, all of a sudden, obviously, someone's going to be arbitraging that decentralized exchange. And miners, again, are going to be able to do that arbitrage and make a little bit more money if they're able to consider that arbitrage as a part of their mining process. The last thing, which is maybe really relevant to today, to the topics at hand these days, is unavailable. If you are a miner, and in order to build a competitive block template, you have to go do something creative in order to get those transactions that are going to pay you the fees, then all of a sudden we have this problem where mining is no longer linear cost per hash, and there's a high fixed cost to be a competitive miner. So if, for example, the filters on the peer-to-peer network do not match the types of transactions people want to make, well, now as a miner, you have to go invest in order to get a competitive block template, in order to make the same amount of money as your competition, you have to invest in going and finding out where those transactions are, getting them into your mempool so that they can be included in your block template. And maybe that's easy, maybe it's just a matter of running, you know, some patch that Peter Todd posts. Maybe it's hard. Maybe it's building out something like Slipstream and having a whole proprietary API, having full-time engineers staffed doing this. You know, as a moderate-sized miner, maybe that's not too expensive, but on a small scale, you know, full-time engineers start to add up real quick. Okay, so hopefully you accept that this is a problem potentially, that there's some risk here, even if maybe it's not super short term, maybe it's not coming soon. But what do we do? I just mentioned that it's terrible that we have all these private mempools because they increase the cost of building a competitive block template. But the solution to this problem is that we need to add a new private mempool. Seriously, no giggles? All right, this is a terrible crowd. So that is in fact our proposed solution. And it's not a solution we're happy with, to be clear. This is our proposed solution is something we're unhappy with, but we think is the best thing we've come up with in order to reduce the impact of this. So we should, again, learn from Ethereum. Ethereum's far down this road, and we should at least see what they've done and see what they've built. And in fact, they did recognize that this problem was a problem before it was necessarily totally wrecked them. And what they built in response was this thing called PBS, Proposer Builder Separation. And so in Ethereum, the proposer is the person who's building the block template, and the builder is the staker, the person who's actually confirming it, or the miner in the Bitcoin case. And so they actually built a marketplace. They separated these entities out, and they said, okay, well, people can bid on block templates, and these folks can bid on it and select the transactions, and they can do all the complicated MEV extraction nonsense, and we can make those separate entities from the actual stakers. And so that shouldn't cause the same level of centralization in staking or mining before it that we're worried about. And this has been effective. It has allowed small-scale small. I mean, you still have to have a lot of money and some hardware, but moderate-scale stakers to be competitive. You can still get a competitive revenue stream from staking, but the problem they do have is that their entire marketplace is built around entire block templates. So because of some technical details in Ethereum that aren't relevant to this talk, it's a little simpler to model their marketplace as whole block templates. And so, of course, the problem is, well, the thing we wanted to solve for was we wanted to keep block template selection decentralized. And instead what they said was like, okay, well, we're going to keep the actual staking part decentralized, but we're going to let the block template selection part centralized, which was in fact not the problem we were solving for. That totally didn't accomplish that. And so that's why, in fact, you see again now 80, 70, 90% of Ethereum blocks, depending on when you look, are OFAC compliant, are in fact censored blocks that do not include transactions that the US government said are bad, for example, among other things. That's because the block template selection marketplace is completely centralized around literally 3 to 4 companies. There's only a few. So there's an obvious solution to this, and that's that we can take this marketplace and we can try to break it out. We can say, okay, well, actually, we're going to build this kind of marketplace for block templates, and we're going to allow specialized entities to do this MEV extraction, but we're going to make them do it on a per transaction basis. So we're going to say, okay, miners, you should still look at your own local mempool. You should still connect to the peer-to-peer network, take transactions from anyone who wants to submit them to you, and include those in your blocks. But then also, if you get these other bids out of band where someone says like, oh, hey, I know how to do this crazy smart contract thing. If you include this transaction, I'll pay you a little more. You include that as a part of your block template. So you don't do only one or the other. You look at both, you merge them together, and you build, hopefully, the most competitive block template you can. There's a lot of complexity here. There's a lot of deceptive complexity, especially in the market structure. So, how do we build this marketplace? Well, we need some weird properties. So, for example, with XXX arbitrage, if you want to do this arbitrage, you need to be able to see what the price is going to be at the time your transaction confirms, at the time the block comes out, because you only want to do the other leg of the arbitrage. You only want to do the 2 legs of the arbitrage at the same time based on the price is fluctuating. You only want to do the arbitrage at the current price, right? At a price you're going to get. So we need the ability to time out transactions, which is something that's not native in Bitcoin, right? You can't broadcast a transaction and say, you can only include this transaction in your block if you mine the block in the next 10 seconds. Can't do that. So we need to do something, and you can't, like a naive marketplace for this, right? If bidders were just saying, like, here's the transaction, please only include it in the next 10 seconds, the miner can look at that and say, haha, thank you, and then include it an hour later, or 10 minutes later, or just include it in their block template, and it might take them 10 minutes to mine a block. So we propose using proof of intel, SGX, right? You could use Nitro enclaves, whatever it is. But you can say, okay, miners, you're going to actually now run, the same server that was already picking your block template, but in the enclave already in your server, in your Intel CPU, you're going to run your block template construction logic inside of that. And so, you might get this bid comes through, and it goes directly from the marketplace. It can authenticate with your CPU, and it can send this transaction through, and your CPU has the transaction data, but it won't release it to you unless you find a block. Right? So the CPU, your local CPU can actually enforce these properties and say, well, this transaction, I'll give you the work to mine on, I'll tell you the stratum job, whatever, and you can mine on it, but then you won't actually be able to see the transaction data. But if you do get a block, I'll give you the transaction data right away, and then you can broadcast the block like you normally would. So this solves the nice problem there. There's a lot more complexity to this, though, right? So the reason that this doesn't exist in Ethereum is you might have a lot of things that conflict with each other, right? So like I might want to be the one who does this XDEX arbitrage, which means I need to be the first transaction in the block which interacts with this smart contract, this DEX, right? And so again, that's why you see the very first transaction in most Ethereum blocks is the one that does some arbitrage between Ethereum and USDC, because they want that the arbitrage has to be done first before some other trades might happen on the block. But if we're trying to do this on a per transaction basis, well, it's like, okay, we can't have two people bidding to do arbitrage on different DEXs, also both wanting to be the first transaction in the block. Well, you could include both of those. They don't care. They just want to be the first transaction in the block to interact with that smart contract. And so we need to be able to capture that in the order, right? So the order for block space, this bid, has to be able to say, okay, I need this transaction to be the first one in the block that has these properties, interacts with these contracts, does these things, and you have to be able to describe that in some programmatic way that still allows miners to build block templates. And then also I need to be, only mined within the next 10 seconds, and that has to be described to the miner. This stratum job is only good for the next 10 seconds, then you got to roll it over, which has hardware implications, but won't get into that. So as hopefully you can see, this is actually not trivial. This is potentially a very complicated thing to build, and it's certainly not something that Bitcoin Core is going to do naively. This is, in fact, has challenging computer science implications, right? Just having these complex relationships between a lot of different things and then trying to do bin packing on them is actually a fundamentally hard problem in computer science. So, which is hard, but in practice, it's fairly doable, we think. No one has implemented this, but our hunch and some existing research on other just general Bitcoin transaction inclusion logic has been that you can probably take it and throw it at a SAT solver or something generic, right? So you can take if you're a miner, you can, a new block comes in, you just immediately start mining based on whatever Bitcoin Core tells you with the public mempool, and then you burn, I don't know, 5-10 seconds of CPU doing some SAT solving algorithm or something, naive or whatever, and then it gives you a block template that includes all of these more complicated bids and hopefully gives you a fairly competitive block template. But you might be thinking, didn't we just say that complex block template construction logic that might allow miners to optimize more was the entire thing we were trying to avoid because that might drive centralization? And you would be right. But we're doing this in SGX. So the nice thing about doing this in SGX is the whole point is that we were proving to the marketplace what software you were running, right? And so, in fact, you're required to then use some open source block building logic. And you, as a part of being in this marketplace, you would be required to use some SAT solver or whatever that hopefully we can make very competitive, so that there aren't centralization pressures that arise out of people being more creative here. But there's some cost to, there's some non-zero cost to, if you were to try to create something that's only 1% better, probably you wouldn't be able to run that because of the structure of the marketplace, because it's running in SGX. Whereas if you were to do something 10 times better, then of course that would be problematic. But I think we're fairly confident that just like throwing a SAT solver at it or something would actually do okay. Yeah, so that's basically our proposal is just like have a marketplace for this. Do the same thing as Ethereum. You have bidders, you have some marketplace, and then you have miners who are running their block building in SGX. Now, this is still very centralized, right? You should be at this point saying like, wasn't the point to have decentralization? Like, what the hell? You're talking about building a centralized marketplace and like replacing Mempool's accelerator with something like orders of magnitude more complicated. Like, what the hell? And like, yeah, this sucks. Like, to be clear, this is not a good outcome for Bitcoin in any sense of the word. This is, as far as we can come up with, the best thing we could build to keep Bitcoin from being even more centralized and having even more centralization pressure and censorship in response to MEV and MEVPool becoming a thing on Bitcoin, not something we're like excited about being the future of Bitcoin. In order for this to be slightly less bad, in an ideal world, it should be open source code that has many competing marketplaces. There's not a lot of cost to running a marketplace. You just, hopefully, if someone builds this, there's just open source software you have to run. But there is some cost, right? You have to get some amount of trust. You have to, people have to trust you to submit their orders through you. Pools have to be willing to use you. The pool's not, or the miner's not really trusting you because they do have the transaction data is locally on their CPU. They're not trusting you to release the transaction data when they find a block or anything crazy like that. But like they might, depending on the structure of it, they might have to trust you to pay. There might be, they bid. They said if you include this transaction, we'll pay you, $5 or whatever in fees. You'll pay you 1,000 sats. Depending on how this marketplace is designed, you might have to trust that the marketplace actually has that money, and then we'll pay you in Lightning afterwards. It could be in the native transaction fee. Again, because these transactions are hidden from the miner inside of SGX, they can't like take the transaction and broadcast it and take the fee for themselves without meeting whatever constraints the transaction is supposed to have on it. But you might also have some reason in the protocol why you can't necessarily include that in the transaction fee, and then you'd have to fall back to like Lightning payments, where the marketplace is somehow holding the money and then paying out to the miner. So there's some cost to having a ton of these marketplaces, but hopefully it could be made fairly low with lots of with open source software and people actually building this and making it competitive. Before I move on, are there any questions about the marketplace structure? I know I went through that kind of quick, and there's a lot to it. I repeat the question, but.
Are there any viable alternatives to the SGX because it's been pwned previously?
Yes, SGX has been pwned many times. There are, there's also Nitro enclaves. There's some other things. I think SGX is maybe okay for this. Like SGX has been pwned many times, but usually it gets pwned like a year after. Like last year's hardware gets pwned today, and then like today's hardware will get pwned next year. And as a part of the proof handshake, you can see what version of the firmware and hardware they're running. So in practice, what you do for SGX is you say like you must be running like yesterday's hardware or like this year's hardware basically. So there's some cost to that. Like miners have to always be buying new hardware, but like all right, it's $1,000 a year or something. It's not actually huge. And I think SGX, like the issues if this gets hacked also aren't huge. It's like, okay, well, some transaction was included in a way that they didn't intend it to be. Maybe some arbitrage bot got kind of hosed a little bit, but like the miner doesn't get hurt, and people would see it. People would be like, oh crap, there's like an SGX hack. Like the marketplace could respond. The marketplace could say like, I'm not working with that miner anymore, which is a risk of this whole thing, is like the marketplaces could say like, I'm not working with this miner anymore. The miner's going to go out of business. But they could respond to those kinds of hacks as well.
All right. I think like the thing that's ambiguous about this to me is like how the order placer actually like dictates the conditions that they have to meet in order for the fee to be paid, and the relationship between that and how the templates are actually constructed, because it's you've kind of not specified anything about like how to actually communicate the order conditions. Like, what do you see as the relationship there in terms of like the complexity necessary in that language to be flexible enough to define the conditions the user wants and how that's going to relate to the complexity of the actual construction algorithm.
Yeah, totally. No, that's a good question. Yeah, I mean, obviously there would have to be. I think the big amount of complexity in the like transaction inclusion requirements language would really just be how you specify the smart contract you want to be the first thing to interact with. Like, I want to be the first thing to interact with this contract, nothing else can go before me. And so it needs to be flexible enough to capture whatever types of smart contracts there are on Bitcoin, whether it's a like merged mine thing, you know, it might be like, I want to be the Coinbase transaction output for this merged mine coin. I want to be the one for that. So you have to be able to say like, you know, you might have a different bidding process for the Coinbase transaction outputs from other transactions. Or if it's like an on-chain thing, you know, if it's like a based rollup or whatever, you know, they're really just embedding data in the chain, whether op return, witness data, whatever it is. So you need to be able to say like, I want to be the first transaction that matches this substring. Like, you know, however, it has to capture whatever that protocol's capture is. Like, however that protocol defines its own thing, you have to be able to capture that. But I think that's still tractable within like the block template building, right? If you take those two examples, like you have, you know, it's obviously very easy to bid for Coinbase transaction outputs, but if you just take the example of like, I want to be the, you know, you can express, I want to be the first transaction in the block that has this substring in it, like, you know, that's pretty tractable. There's obviously complexity because you might have overlapping transactions. You might have this one that says, I want to be this first transaction in the block that has this substring, and this one that says this substring and this substring, and you have like OR and like Boolean logic across them, which gets complicated, but I think we're fairly confident that you kind of throw it at a sat solver and it's like, okay, it'll be slow, it'll like burn your CPU for a little bit, but as long as it spits out a block template in a few seconds, and most of them probably will, I think in practice it'll work. It's just the theoretics of it are like, you know, in like a theoretical computer science thing, it's like, oh, well, that could take infinite time. That could not work at all. But it's like in practice, probably it'll be fine, which is true of most sat solving to begin with. Is like a lot of the sat solvers are like, they actually work very well. But, you know, obviously they're solving an NP-hard problem and they don't have a general solution.
Hey, when you're talking about potentially moving to like the next thing, if things get pwned, one of the things that you mentioned was Nitro Enclave. But is there like, are you just talking about this in general? Because I'm sure you're not talking about we should all be running stuff in the cloud. Because no. I know you're like anti-cloud.
Yeah,
so
no.
What, like, were you just using that as like a fictitious or just like a random example? But
yeah,
not, okay.
I mean, AMD has another one. ARM has trust zone stuff.
Because I wasn't sure, because technically, like if you want to talk about getting into the hardware, doing side channels, or like, you know, doing something with the hardware, it's probably a lot harder maybe to get into an AWS data center than another data center.
It's true.
So I wasn't sure if you were being serious or not.
No, I mean, I think that would also be a bad outcome for Bitcoin.
Right,
That like all miners must run their mining block template selection at AWS. But
okay.
It's, you know, I hopefully not. Hopefully SGX were to work out. But, you know, maybe it's ARM Trust Zone, maybe it's AMD's version, or, you know, if it gets worse, like that's still better than, oh, sorry, only a few miners can compete, or everyone has to use one of two big mining pools because only those two big mining pools can competitively build block templates. Like, I would rather everyone has to use AWS and at least anyone can buy that versus like, sorry, everyone has to use Foundry and Bitmain and those are the only two options. Nobody else even exists, you know. There are layers to how bad things can get. And like even anyone having to use this to begin with is like bad, you know. Any other questions? Everyone's kind of got the like concept.
I just want to make sure I understand how the marketplace fixes the problem. So I think it sounds like you're concerned that like MEV kind of becomes this like arms race to like increase margins, so everybody ends up, you know, becoming MEVPool, and it becomes really, really expensive to make a block template because everybody wants to do all this like market arbitrage. So the marketplace that would run in the enclave that you're proposing, I guess I'm a little confused as is the person or the party running this enclave, like, is that enclave expensive to run? Are they making bank by running this enclave?
Oh, no, so yeah. So the enclave exists on the mining side. So the miner would run at, in SGX or something. That's fairly inexpensive. You can buy hardware, whatever. And that's running open source software that builds the block template. It's really the expensive part is the people submitting the bids on the other side of this order book, right? So the people who saying, hey, this transaction, I want you to include it in this part of the block and whatever, and then I'll pay you a bunch of money if you do that. That's, we imagine, going to be very expensive, and it is in Ethereum, right? It's like you have these high-frequency traders who are like submitting these, and they don't have to run in any kind of enclave or anything, but they do want proof from the marketplace, or at least the marketplace has to prove that the place that their bid is getting submitted to is running in an enclave, because they want to know that, like, here's this transaction that I'm creating. I don't want this to be included in the block unless the block is mined in the next 10 seconds.
And so the logic for handling the inclusion in the block, like if it expires or what order it needs to be a block, would be in the code that runs in the enclave, and that's how the arbitrage people submitting these bids can kind of validate that it will be honored. And ideally, this would be affordable enough to where like a small mining pool or a small mining operation could run one of these marketplaces in theory.
Yeah, I mean the marketplace doesn't have a lot of complexity to it either. It's hopefully also open source code. Anyone could just run one. And then of course, yeah, the thing running in the enclave is just like, well, you have to have an Intel CPU. You have to have whatever the brand of CPU is, but that's pretty doable. All right, so I'm just gonna go to the last slide, and then we'll have another minute for questions. So the last question is just kind of like, oh, well, all right, what does this mean? Like, you proposed this crazy idea, this like terribly centralized marketplace that like might allow these marketplaces to tell miners they can't function. Is this something we need to like build now? Is this like, an immediate worry? Are we like screwed? And the answer, of course, is like, I don't know, right? Like the MEVPool question is like the $1 million question on all the covenant stuff and a lot of the like future of Bitcoin, like where do we go from here, is like, I think everyone wants to do all covenants if we don't have any MEVPool questions, right? If we want everyone to be able to do anything they want with their coins as long as it doesn't impact the whole network overall. But if we end up with MEVPool, if we end up with these big dexes on chain or something, and there's reasons to think we won't, there's reasons to think we will, whatever, then that would kind of wreck Bitcoin. So, some people have argued it's fait accompli that we'll have MEV in Bitcoin, that we'll have this MEVPool stuff because it happened big time in Ethereum. It's been happening, basically anytime you have any kind of level of complexity, you might get it. And so we should just accept it and we should do what we can, but like, it's not a problem. I don't really think it's a given, but it depends entirely on what people want to use Bitcoin for, right? Again, like we can't stop people from embedding data on the chain, and it just takes a merge mine blockchain to bring MEV to Bitcoin, right? That people use. Like people, a big question about MEV is like people have to actually use it, right? There exists lots of MEV kind of contracts in Bitcoin. There do exist dexes on Bitcoin. It's just that no one uses them, so it doesn't matter, right? Like, okay, if a miner is super clever, maybe they can make another 1,000 sats per block, yay, who cares, right? But if people were to actually use it, then all of a sudden it starts to add up and it starts to become an important part of the block template process. But yeah, so it depends on what people want to use Bitcoin for, and really it's, in my view, we should be taking this type of thing seriously. We should think like, okay, is this actually the best thing we can do? If it is, then probably we should build it. Like someone needs to sit down and build this before we start running ahead and saying like, all right, let's enable all this functionality that people are going to use for bridges to based rollups that people are going to use for whatever. I think there's reason to think that people probably don't necessarily want based rollups now, but if you could do BitVM without the one event assumption, maybe you would. But like, I think we should probably build this because it's the best idea we have, even though it's shitty. But someone needs to actually sit down and build it. Anyway, that's all I got. Any questions?
You described all the reasons that you don't think this would be a great thing, but it would be better than the other alternatives. Do you have any idea of like how much extra revenue you would have to see from a MEV or a MEVPool miner before you decide, yeah, this is worth turning on? Like, is it 5% extra revenue, 20%?
Yeah, it doesn't take much, right? Like if you're, mining revenue, the margins vary a lot, right, based on the Bitcoin price and like whether the Bitcoin price was up last month or next month or whatever. But mining margins tend to not be that high. They're often negative in some cases, when the price is down. I think all the current miners might tell you margins are always high, but if you talk to the miners from 3 years ago, they'll be like, margins are terrible. So, they tend to be fairly low on average, maybe, hopefully in the long term they will be. And if you have fairly low margins, well, okay, if your margin's 10%, 1% increase in revenue is huge. I mean, that's like going to lead to heavy centralization pressure. So it's not clear to me, my preference would be that we just build it now and hope it doesn't get used. Like, there's not a lot of harm to this thing existing if it doesn't get used, because it's like, all right, well, miners can just ignore it. At least it exists. People who want to submit transactions can do it. But, it's like, Slipstream and Mempool Accelerator. It's like, if they were used very heavily and it were like a huge portion of the revenue, of miner revenue, then that would be really bad. But as long as they're not used that much, it's like fine, totally fine. And so I think there's like, it'd be nice if it existed either way.
Hey, it seems like MEVPool conversations typically pop up when thinking about different upgrade proposals. Most of the upgrade proposals that people are talking about these days seems like it's ambiguous, or it's at least not super clear if MEVPool would happen imminently. Are there any proposals that you see that you're pretty confident that, like, if that was activated, MEVPool would pop up?
I'm not confident in any of this stuff.
Or at least,
I
is
think,
there anything that would like genuinely worry you?
So I think the problem is I'm not confident in any of this because it depends so much on you really have to think third order of like, well, okay, people can build this thing. Will they actually build it? And then will people use it? Like, is it going to get big if people were to build this thing? And so that's kind of why I mentioned like BitVM. Well, okay, you could build a based rollup today, but you already have this like one event trust assumption, so why not just sequence it? And so like it's probably not necessarily going to be a thing, but like, okay, if you were to imagine we add some soft fork, we remove the one event trust assumption, and now I could start to see like Bitcoiners being like, well, I could use this centrally sequenced rollup, or I could use this based one that's decentrally sequenced, and now I have a better, it's more decentralized. It's better. I want to use that. Like, you could start to see marketing working there. And so it's not clear to me, but I mean, those kinds of things would start to worry me more.
Final question.
So, I mean, it seems to me like we are going to have some hints as this is developing. And to be fair, we are kind of arguably already seeing this with things like ordinals and the rare stats and all of this stuff, right? Like some level of MEV is already happening. And that will continue to happen, even regardless of a soft fork, in my opinion. I mean, with meta protocols and sort of embedding EVMs into meta protocols and things like that, there's absolutely a universe where this happens pretty quickly, regardless of a soft fork. And so my question is like, how fast can this be built? Like, how big of a project is this? Like, is this something we really need to prep in advance? Because this is something that could take off really quickly. Like, you could have like a meta protocol that like goes crazy, and then it's like a 6-month situation, and all of a sudden this is what's going on.
Yeah, I mean, it's not trivial. It could totally be built in stages, right? You could build the marketplace without the SGX part so that you don't have the like ability to time out transactions, but at least you can accelerate some types of transactions and like pay extra for them, which depending on the type of protocol might work, might not work. But yeah, I mean, if you start getting into the like whole, like the transaction selection being super complicated and needing to like throw a SAT solver at it or something, it might not be trivial at all. I mean, it might be like a really serious engineering project. And then getting it to run inside of SGX has its own challenges, which might also be a very non-trivial engineering project. So I would not suggest that we sleep on this, but I also don't have, like, I don't know, I would need someone to be interested in wanting to do this. It's hard to find devs. I don't know.
I know some. Let's talk.
All right.